be Ari. Ari.
Ari.
Ari.
Ari.
Ari.
Ari.
Ari. So Ari Eitan is a security researcher and incident response professional. Ari served as the head of the IDF incident response team and has vast experience in dealing with nation-sponsored cyber attacks, specializing in malware analysis, reverse engineering, and forensics. He has spoken at a variety of security conferences and trainings, mostly for government organizations and international agencies. Currently, Ari is the VP of Research at Intezer Labs, an early-stage cybersecurity company. So, Ari, the stand is yours.
Thanks. So, can you hear me?
Yeah.
Okay. So, hi everyone. Before we start, I would like to introduce myself. My name is Ari Eitan. I used to be a security researcher and the head of the IDF CERT team, which is the incident response team of IDF. My team and I took care of every cyber attack on the IDF in the last 3 years. I helped to build incident response teams at various government agencies, and today I'm the VP Research at Intezer Labs. We're developing a technology for security teams that enables very fast and very deep analysis for cyber threats. We provide a cloud service that gives reverse engineering level insights to deal with unknown files and memory modules. We're launching soon, so I invite you all to subscribe via our website and to stay tuned. I've handled many cyber incidents, and during my work, I managed to handle real APTs, which targeted Israel and the IDF on a daily basis. So I'm very familiar with this incident response world, both as a researcher and as a team lead. Today, I'm going to show you a very useful and cool open source project that we developed at Intezer that allows you to do large-scale reverse engineering. Let's start with the current state. Guys, you're all aware of this problem. You have huge alerts in your company, and you need to investigate a lot of files. You can get those files from your incident response team, from a hunting activity, or the forensics team. And after a basic file filter, you still get with a bunch of unknown files. And I want to focus on them because you have to determine whether they are good files or bad files, and you don't know so much about them. The dealing with unknown files is a common problem which may have caused you to spend time in the wrong places instead of focusing on the real threats. There are a few solutions in the market that try to help you with those files, and the most popular are sandboxes. But you've all used sandbox, and you all know that most of the time it's just not good enough. You can get equivocal results or superficial results, and eventually to really understand the file that you're dealing with right now, you have to do reverse engineer to analyze it. It's not a secret that in some companies they don't even have the personnel for those kind of things, and they usually just stop after the automatic solution, whether if they got the answers or not. In the ideal situation, I would like to reverse engineer all my unknown files, but as you know, that's not possible. Reverse engineering is a very time-consuming process, and you have a lot of files to investigate. As a researcher, it would make it easier for me if I could automate the reverse engineering process, or even some of it, on a huge amount of files. This is what we call large-scale reverse engineering, and that's the best scenario because then we can reduce the amount of time per analysis, and we can get more accurate results. So why hasn't anyone done it yet? The reason is because the current reverse engineering tools are just not made for automation and scale. Each of the tools has its own reasons, but they are all counting on very complex user interface, which built to work with humans and not with machines. I have two examples right here. IDA and OnlyDBG, very powerful and useful tool in the reverse engineering community. And as you can see, they have a lot of buttons and windows, and they're not just simple tools. It's true that there's a way to automate those tools, like IDA Python for IDA, for example. But still, if you want to execute an IDA Python script on a lot of files in a very short time, you have to do it at scale. And there's no comfortable way to do that today. So as you can see, there is not a good solution for large-scale reverse engineering, and this is exactly what we're trying to solve. Now let's talk about how I want it to be. I would be thrilled if I could have a cluster of machines that knows how to do reverse engineering, where the machines just wait for me to send files to them. Kind of like creating a reverse engineering army that waits for my commands. Then we could take all the unknown files that I have and send it to those machines with an analysis, like IDA Python script, for example, that would run on every one of the unknown files that I just sent. When the machines finish the execution, they can save all the results into one place. Now, if we'll be able to do this, will make cloud-scale reverse engineering from something that is not possible to something that is possible and fast. So I have good news. We were able to do it. And let me explain you what we did. First thing we had in mind when we realized that we need to do scaling is a trend from the development world, very hot trend in the last years, which called containers. And I'm going to talk specifically about Docker container. Who heard about Docker? Okay, so I see that some of you heard about it, and I'm going to explain that shortly. Docker is a tool that enables you to ship or move your software from one environment to another in a very comfortable and stable way. You can think about it like mini virtual machine for a specific process. Let's say, for example, that you want to ship or move your software from the development environment to the test environment. You just need to make it work on Docker, and then you can ship the Docker container, and that's it. Now, I don't want to talk about Docker too much. It's also hard to explain in 5 minutes. But what you need to know is that Docker is a very good solution for scaling. Let's say that you want to scale your software. You just need to make it work on Docker, which is not going to be easy. But then you can just send the Docker image with your software on it to all the servers that you want it to be deployed there, and that's it. You created scale for your software. We realized that if we combine the power of Docker container with a way to automate the reverse engineering process, we'll get to our wanted goal, which is large-scale reverse engineering. And now I'm happy to show you our solution, DrIdea. DrIdea is IDA installed on Docker container with a very comfortable interface for analysis execution. With it, you can create huge cluster, which is going to be the reverse engineering army that I talked about, and execute an IDA Python script on millions of files in a very short time. DrIdea is the infrastructure tool, but still you have to add your analysis to it. You need to write it, and this is the IDA Python script that I talked about. You can write it according to your knowledge, your skills, and the needs of your organization. Just for you to know, creating this project was not easy, and we spent time on research, development, and customization. We even had to reverse engineer IDA for it. But eventually, we created a very comfortable interface to create the Docker IDA cluster and to communicate with. And I'm going to show that to you at the live demo. The reason that we decided to do this project at Intezer is because we have the need to analyze malware at mass scale. And this is some kind of side project that we did. And we decided to make it as an open source. So it's on our GitHub repository. It's for you guys, for the community, and you're more than welcome to use it. Now, let's talk about the general workflow before we'll see a live demo. First thing you need to do in order to work with DrIdea is to create a DrIdea cluster on your machines. Don't worry, we already did all the hard work, and there is a very comfortable interface to create it, and I'm going to show that to you also at the demo. And once you finish doing that, you need to write your analysis. This is you guys writing the IDA Python script according to your needs and your skills. Once you have the analysis, you can send the analysis and the IDA Python script and the unknown files to these machines. The analysis would run on every one of the files that you just sent, and when the machines finish the execution, they can save all the results into a shared folder, some kind of database, or basically whatever you prefer. It's totally up to you. All that's left for you to do is to go to this place, get the results, analyze them, and get your conclusions. It's that simple. Now, I want to show you a live demo. You want to get over it?
No, not funny? Okay. So while our pal here gets ready, again, a reminder, we have, after this talk and after this live demo, which is a lightning talk, we have just 2 more speakers. The next speaker after Itai is going to be Amit, and he's going to talk about... Sorry? Ari. I'm sorry. This is Ari, of course.
You say my name too much.
Yeah, it happens to me all the time. After Ari, we have Amit, who's going to talk about OS X. That's the Apple OS and the vulnerabilities. His talk was recently featured at Layer 1, a conference in LA, and it was voted the best talk of the conference. But after that, which is a tough act to follow, we have our secret guest speaker, whose identity is unknown, but known to most of you. And then it's party time.
So yeah. So first thing you need to do in order to use DrIdea is to build the DrIdea image on your machine. Let's say that you already downloaded all the files from our GitHub repository, and now you need to build the DrIdea image on your machine. Don't worry, it's very easy. It's one command, and it's well documented on our GitHub repository. And after you do that, you can create instances of DrIdea and start building your own DrIdea cluster, which is exactly what I'm going to do right now. Okay. You don't need to look at the specific command because it's also on our GitHub repository. But with one command, I'm creating a virtual machine that runs IDA. Okay, that's it. We have a cluster with only one instance of DrIdea, and I'm going to run another command, which is exactly like the previous command, only the ports are different. And now we're going to execute this. Enter the sudo password. And that's it. Now we have a cluster with 2 instances. That's more than enough for now. And that's the end of the first stage. Now we have the reverse engineering army. Now we're moving to the second stage. We need to write an analysis, which is an IDA Python script. So I wrote a very simple IDA Python script. And I'm going to show that to you. I hope that you can see something, but I'm going to explain that anyway. Okay. So in this specific case, the script, the analysis, just counts the amount of functions per file, per binary file, and saves it to an output file. I hope that you can see it, but I'm just I'm going over all the functions, counting them, and eventually I write the counter to an output file. That's it. It's not a very complex analysis, but that's good for the demo. And that's the end of the second stage. Now we just need to have files to investigate. So I have 8 binaries from virus share that I want to execute the analysis on them. So now we're ready to start. We have the cluster, we have the analysis, and we have the files. Now we can just send all the files to the cluster with the analysis. Now it's going to take a few seconds. But eventually, and remember that it's going to take a few seconds because we're talking on my virtual machine. If you're going to deploy it on a real powerful server, then it should be much faster, and it's going to be much faster. And eventually, we should get an output file per file that we investigate, which means 8 output files. And I don't know if you can see the message, but it says check the output folder, which is, in this specific case, it's the original folder. And I'm not sure if you can see it, but for every binary files that we had, now we have an output file. And if I'm going to open the output file, it's a txt file. And we can see that we have, in this specific binary, we have 91 functions. Okay, now let's open another one. So you see that I'm not bluffing. Here is the second binary. And we have 406 functions in this file. So I know that the output is a txt file, and I know that we're talking about only 8 binaries. But what I wanted to show you is that we can execute an IDA Python script on a few files, but you can do it on a lot of files, and in a very short time. And see how easy it is to create a DrIdea cluster, to build and add new instances to this reverse engineering arm. Okay, that's the end of the demo. So, as you can see, DrIdea is a very powerful tool, and there are many use cases for it. I'm going to give you a few examples just for you to see what you can do with it. For example, you can do automated unpacking. Let's say that you have a bunch of files that are packed with the same packer, and you already unpacked this packer once. You don't need anymore to open every file individually on IDA and only then execute the unpacking script. You can just send all the packed files at once to the DrIdea cluster with your IDA Python script, and that's it. In the same way, you can also do string deobfuscation. If you already opened obfuscation once, you don't have to do it manually for all the files. And if you want to search for vulnerabilities, you can also do that. You can search for buffer overflows using PyEmu, or search for rope using IDAsploiter. Or basically, it's Python, guys. So if you can write a script on it, now you can execute it on a lot of files in a very short time. This is the greatest value of DrIdea. Now, I want to demonstrate you the power of DrIdea, and for that, I'd like to show you the results of the POC that we did at Intezer. In a sentence, we collected 1 million malwares from all over the internet. We created a DrIdea cluster with 100 instances, and we wrote an analysis and executed it on a lot of files, on million files, in a very short time. It only took us a few hours. Now let's go deeper. We collected 1 million malwares from all over the internet. I'm talking about real malwares. It's not something that we generated or something like that. And the reason that we took this huge amount of samples is because it's not likely that a researcher will be able to handle this huge amount manually. And that's why he'll need DrIdea. It took us 10 minutes to create the DrIdea instances because of the very comfortable interface that I just showed you. And we wrote an analysis. In this specific case, I wanted to get the most popular capability per file. So we wrote an analysis that just counts the amount of calls per API function inside a file. Then we grouped together APIs with the same category, and we took only the highest category per file. Okay, and here are the results that you see right now. We can see that for 40% of the files, the most popular capability is file input out. Remember that we're talking about 1 million files. And right after that, with 20%, dynamic link libraries. That's nice. I want to show you another analysis. And this time, I want to deal with the ransomware problem. As a researcher, if I get an unknown file and I want to determine if it's a ransomware or not, maybe it's potential ransomware, I'm looking for a specific pattern. I'm looking for a call to a crypto function inside a loop that iterates the disk. This is my analysis. Okay? And now, I took this pattern and I wrote a script for it, and I executed it on all those files in a few hours. And here are the results. You can see that 1.6 of the files out of those million files answers this condition, which means that according to my pattern, they are potentially ransomware. Now I can decide whatever I want to do with them. Maybe I want to skip on them, remove them immediately, or maybe I want to focus on them. But that's up to me. So as you can see, DrIdea is a very powerful tool because things that you could do only manually, now you can do automatically. And things that you could do only at one file at a time, now you can do on a lot of files. So how could you use it? Just like I mentioned, DrIdea is on our GitHub repository. You're more than welcome to use it. Few companies already did it, and the reviews are great. And if you need help with performing deep analysis or with the DrIdea project, talk with us. We'll be happy to help. That's it, guys. Thanks for listening. If you have any questions, then you can talk with me. One question. Tamir, you can talk with me after. We're using IDA. It's DrIdea. Oh, okay. So this specific version of the project is working with IDA. But if you want to add a DrIdea project, you're more than welcome to do. Yeah, so license. If you're running all the instances of IDA on the same server, that's fine, but you also need to talk with X-Rays about it. Okay?
Who is the customer?
Everyone, it's an open source project. If you're an easy response team and you want to execute an analysis on a lot of files, you can do it that way. If you are a hunting team and you did a hunting activity and you have a lot of files and you need to investigate, you can also use that. You can use it for many use cases. Okay, thanks.